Ospf routers connected by a switch on a broadcast network want to form an adjacency with every other router with which they exchange hello packets. This can be achieved by using a full mesh, so every device can speak to every other device. But this can be problematic because as more routers are added, the full mesh requirement of n times n minus 1 divided by 2 increases with no additional benefit because all link state devices have the same link state database. To avoid this issue, Ospf assigns a designated router, DR, to form an adjacency with all other routers on the link and to advertise the link state information to the area. A backup designated router, a BDR, is also elected in case the DR fails and forms an adjacency with all other routers on the link, but doesn't advertise the learned link state information. The DR is elected based upon two criteria: a higher priority first, and if the priority values are the same, then the highest router ID. A priority value of 0 means the device is not eligible for the DR election. All other routers are called DR others. We could also change the interface type to point-to-point, stopping Ospf from performing a DR-BDR election on that link, saving the extra time it takes to perform a DR-BDR election. However, please be aware, the point-to-point interface type only allows one neighbor, so you'll have to use different interfaces or sub-interfaces to connect to multiple Ospf routers. Finally, if you think that the size of your Ospf area is getting too large and you need to reduce the size of the link state database, this can be achieved by using multiple Ospf areas rather than one huge single area and performing route summarization on the borders between Ospf areas.
If you're enjoying the content, please consider subscribing as 86% of viewers aren't currently subscribed.
It's time to look at the DR-BDR operation in Ospf. This is the diagram that we're going to be using. R1, R2, R3 and R4 are all connected through a switch on the 10.1.124 network in area 0. What I will also do, I will give them a loopback corresponding to their router number. So R1 will have a loopback of 1.1.1.1, R2 2.2.2.2, and so on, with R4 being 4.4.4.4. I will also make sure they all join on their interface G000 rather than like 145 over here. So I have 4 routers already set up. Let's just see if we've got reachability. I haven't done any Ospf configuration on them yet, but I have configured their IP addresses. R1 should be able to ping R2, R3 and R4. Let's just choose like R2, yeah, and R4 just as random, yeah. But they shouldn't have any reachability to each other's loopbacks, which they don't, and that is when we advertise those into Ospf, then we should see that. Also, according to the animation, all of their priorities are the same. When we configure Ospf, all of their priorities will be the same. So it will be the router with the highest RID, which will be R4. So I'm expecting R4 should become the designated router. So let's do that Ospf configuration and see if that's true. Alright. I will probably do the Ospf configuration under a notepad, but let's do it here first. Edit protocols Ospf. And I'm not going to do any static router ID configuration under the routing options. I'm just going to leave it as it is by standard. Set area 0 interface. Let's just say all. That's the easiest way to do it. And let's commit. And I'm going to do that on all of them. And I should be able to copy and paste that on all the devices. R1 is done. R2. R3 and R4. And let's see if we have any neighborships. And we can see here that the priority is 1 to 8. I would expect these to say full by the time we're finished. Alright, they're taking the time. This is now transitioning to the X start state. Oh, we've actually managed to see the exchange state. Remember in the last video we didn't get to see the exchange state, but here in plain view we've managed to see the exchange state, which is beautiful. And we now can see that 2 of the routers have transitioned into the full state. I'm not sure why this one is still in two-way. Oh, I am actually sure, because I would expect that R1 and R2 are DR others, so between them they're going to be two-way, and the full state is between every other router and the designated router and the backup designated router. So I'm expecting R4 to be the designated router. Which it is. Excellent. This is because it's had the highest router ID. Now if I wanted to change that, as we saw here, all of their default priorities are 1 to 8. And I think it's the one with the highest priority, the router with the highest priority, which becomes the designated router. But it isn't preempted, so I would have to clear the Ospf processes, and then the router with the highest priority will then become the designated router. And what I will do, I will change the priority on R1. We'll clear the Ospf processes and we'll see if that R1, whether R1 takes over the designated router state. So under the edit protocols Ospf, edit area 0. So for area 0, I'm going to set the priority, set the, is it interface priority? I would have thought it's just the priority, but let's have a look. Okay, no. So set interface GE00.0, the priority as 150. Now, I think it goes up to 255, I would presume. Yeah, from 0 to 255. If you set it as 0, it doesn't even take part in the BDR-DR election. But we're going to set it as 150, as that is higher than 128. We're going to commit that. Run show Ospf neighbor. Now we can still see that the priority hasn't changed here, because you have to clear the processes. Run show Ospf interface. We are still a DR other. And we're showing that we're the DR, but that's only towards the loopback. We don't need to worry about that. We are a DR other, and we can see that the DR is still 4.4.4.4. Now, because we've changed the priority, there are 2 ways we could do it. We could either change the router ID or the priority. We've changed the priority. We would have to clear the Ospf neighbors on all the routers. Run clear Ospf neighbor. Let's just say area 0. See if that will work. Okay, let's take that command and run it across everywhere. Run show Ospf neighbor. Gone into Xstart. We can see that now the neighborship will change, where we say run show Ospf interface. That might be a better command. we can see now that the designated router is 1.1.1 for all of them, whereas our BDR has stayed the same as 3.3.3.3. And that is the way that we can change the actual designated router. And what we could do, if we look on R1, if we run the show us Ospf neighbor command, we should see that I was actually expecting our priority to have changed to 1, 2. Sorry, let's have a look on one of these. Our priority to R1, where is that going to be shown? Here we go. So we can see that the priority of R1 is 150, and that is why it has taken over the designated router position. All right, another thing that we could do is we could change the interface type to point-to-point. Now, we will find that because the dead timers are different in the interface point-to-point, it wouldn't actually cause... You might cause some confusion if you choose one side as point-to-point and the other side as leave it as standard broadcast. Now let's try that actually. Set interface GE00.0 interface type as point-to-point. Let's commit that just on R3. So R3 now should not be taking part in the BDR-DR election because it's an interface type point-to-point which doesn't take part in these elections. Let's see what happens with the neighborships. Run show Ospf neighbor. And the Ospf neighbors have gone. We can still see that this interface is advertised in Ospf, but now it's point-to-point. We don't have a DR, we don't have a BDR, but we're still part of Area 0, but our neighborships have gone. And when we run show us Ospf neighbor, we can see that R3 has gone into the init state. And that's because it's a point-to-point interface. So what we're going to do, we're going to change all of the interfaces to point-to-point. And actually, what I'm expecting here, because they're on the LAN section and a point-to-point is only supposed to be between two neighbors, I'm expecting only one adjacency to come up. So maybe it'll be an adjacency between R1 and R4, or maybe we'll see an adjacency between R2 and R3, but we shouldn't see an adjacency between all 4 routers because they're going to be changed to point-to-point. Let's try that. So edit interface. Okay, it doesn't like it with edit. Let's say set interface GE00.0 interface type as point-to-point. Commit. And I'll run that across all of them. No neighbors have come up at all. Okay, so I'm gonna get a neighborship with between R1 and R3. Nothing on R2. Oh, R2 and R1, but it stayed in an init state. R3 and R4 is full. So we've got one between R3 and R4, and I would expect one to come up between R1 and R2 maybe? No. And the other ones will just stay in init state. So the only neighborship, they've all tried to create a neighborship with R3, but the only neighborship that's come up is between R3 and R4. Now R1 and R2 are being rejected by R3 because R3 already has a point-to-point connection with R4. And these ones, I would presume they will just stay in the init state. So R2 has tried to join with R1. R1 has rejected it because it's trying to join with R3, and R3 has rejected R1 because it already has a neighborship with R4. Alright guys, well thank you for that one. I'll probably do areas in the next one. Let's move on to the next lab.